Hello and welcome everyone to the June Integration Down Under. This group was put together by myself out of Melbourne, Martin Abbott from Perth, Dan Toomey from Brisbane, Renee Browers from Sydney, and Wagner Severa from Auckland. So that's our organizers, all very involved in the integration space. And tonight we have Emad talking about Azure Functions and Kubernetes. And this is actually, it's kind of indulging one of my passions because I'm getting a lot of people talking about running functions in Kubernetes. And this is going to be a real interesting topic for me. And just to give everybody a little bit of a news that the Integrate to London conference last week, Microsoft also announced a private preview on logic apps running in the same runtime as the Azure Functions. So this is really has a lot of implications. So this is going to be a very interesting talk about how we're going to be able to leverage the running your logic apps pretty much anywhere you want. And I think one of the big draws from me from the like the AKS side of things, it's actually the cheapest way to run your functions inside of a VNet. Because if you look at like the app service environments and then with Logic App, the ISEs, they're very expensive, where running the AKS requires a VNet. So you're in a VNet to start with. So this is going to be really good. And the changes to Logic Apps are going to really be good for that. So without any further ado, I'm going to pass over to Emad and let him continue on with his presentation.
Thank you so much. Thank you so much, Bill. Let me just share my screen and make sure that we are set to go.
Looks good.
Awesome. All right. First of all, thank you, Bill, Dan, and everyone who's involved in organizing these sessions. It really means a lot to everyone who is attending and speaking. It's really awesome effort, so thank you so much. And thank you all for coming along today. I'm sure that you have some priorities and things to attend to, but yet you're here, so thank you also for coming to this session today. All right, so we are talking about Azure Functions on Kubernetes today, which is a really interesting topic because in the last or recently, in the last couple of months or maybe a year now, everybody has been cheering for serverless, and it's for a really good reason. Like the aspect or the idea of not to have to manage servers is awesome. You just throw your processing unit, you throw your function out there. You don't worry about servers. You don't worry about patches. You don't worry about down period. It's all taken care of you. And we know that Microsoft has Azure Functions, which is the main processing serverless service that is provided. And it's been also being awesome. Like everybody loves it, and it has a lot of awesome features. But then Microsoft also said, you know what? You can run Azure Functions on Kubernetes. Wow, this is like, when I saw this, like, this is brilliant. You can run Azure Functions on Kubernetes, but the question is like, why do you want to do this? Why do you want to run your Azure Functions on Kubernetes? Well, in order to answer this one, we have to look at two main features in Azure Functions in specific and functions in general. The first one is the concept of function as a service. Now, it's not a secret now, microservices is beyond the hype now, and people are doing it. And it's really compelling concept to have your smallest processing unit as a function. Something that's very small that you can look at once, and you can relate and logic about the concept or the code that is being displayed. You know exactly what it's trying to do. And if you want to fix it or maintain it, it's a one single unit. So function as a service is very compelling part of the tendency towards microservices and this world of small processing units. Now, the other interesting part of Azure Functions is that it has a really nice and rich feature, which is bindings and triggers. So with a very simple declarative way, you can trigger your Azure Functions and provide input to your functions so that all this plumbing is taken care of. You don't have to do it yourself. So you can connect to things like Azure blob storages or queues or Cosmos DB or even external services like Twilio. You go to your Azure function, you declaratively define the connection strings that you want, and then suddenly all the plumbing that is connected to that service, listening to that service on the events that's happening, pulling the input and providing it as easy for you as a parameter your function. This is really awesome. And it's also the output binding as well. So you don't really also have to put a lot of effort in writing the plumbing to write to these services. All of this is taken care of you. And there's a lot of triggers out there, and there's a lot of external extensions that can be deployed to Azure Functions to utilize bindings that do not exist in the built-in Azure Functions. So, Emad, are you saying that we should move from serverless to Kubernetes? No, absolutely not. What I'm saying is that organizations who already have constraints around their environment, things like they already have invested a lot in their Kubernetes infrastructure, or they want to make sure that all the concerns that related to their production is contained in a single environment, or maybe they are just they don't have a real choice as a team to choose which cloud provider, and they love Azure Functions and they want to use it. All of these constraints, they might come in and influence your decision of, you know what, I like Azure Functions, I want to run it on Kubernetes, and I can. But how does this work? Like, how does that Azure Functions really run in Kubernetes? Well, it's a simple idea, actually. In Azure Functions, there's two main components that enable Azure Functions to run beautifully as a serverless. There's something called the scale controller that takes care of invoking your functions of HTTP and scaling your Azure Function instances. And there's the runtime, and it used to have the bindings. Maybe in the latest versions, bindings are external, but it's a runtime that runs your function itself. So the team behind Azure Functions took this runtime and made it available as a Docker container. You can pull that image, you can use it and build your Azure Functions within it, and you can deploy it to clusters and go ahead with it, which is awesome. And today we are going to see this. So without further ado, let's see some code, shouldn't we? I'm going to open the terminal. It's very hard to present for a virtual audience. If you have anything, just send a message to Bill and let me know if anything, like questions or anything. All right, so I have a folder in my playground that's called Azure Functions Cube, and then I have the directory down under. All right. Now we have an empty folder here. There's nothing. So I have installed the Azure Functions Core Tools CLI, and we are going to use it to create a new function. In our case, we are going to initialize it first because there's nothing. I'll be prompt to choose which runtime I want to use. I'm going to use .NET. And once it finishes, you can see that it created a couple of files for us. It created the project file that is going to host our functions that we haven't created yet, a host.json that defines the extensions that needs to be used, and some other parameters, and the local.settings.json, which has the parameters for you to be able to run the Azure function locally. All of this right now is not anything beyond what you normally do with Azure Functions. Let's go ahead and create a new function. And for this one, we are going to choose queue trigger. This is normally the most common integration scenario that we have. Like we have a queue, and we have a function that listens to that queue. And once a new message comes to the queue, we trigger the Azure function. Of course, there's other scenarios that are brilliant with Azure Functions. This is what we are going to concentrate on in our demo today. The function name is, I'm going to call it myfunc, because I grew up with demos that start with my something, my object, my class, my func, my function. Awesome. Now, let's see what we have now. We have the my function file in addition to the files that we mentioned earlier. So let me open this. All right, this is the previous workspace. I'm gonna switch to this mode. All right, let's increase the font a little bit. Thank you so much for your messages. All right, now we have a function that you can see that it's a queue trigger. This is the binding that we have with also in the project file that says we need an extension of queues. If we go quickly, it's this one. And we are listening to a queue called myQueueItems that lives in the connection string that we have in private. This is where we are going to provide the connection string as a parameter to our function. Behind the scenes, I already have created a queue that's called myQueueItems in my Azure environment, where we are going to execute on. Before we continue, just to make this interesting, because we are going to hammer our function a little bit later in our demos, I want to make sure that we are sleeping at least for 1 second in our demo, so we can resemble that this is really processing and doing some work, rather than consuming all the messages that we are going to throw on it. Another thing that I'd like to do is I'm going to, in our extension definitions or properties, we are going to, oops, not this one. We are going to say for the queue's extension, I want the batch size to be 1. I don't want to be able to consume 16 messages at a time. I want to consume 1 message at a time to resemble slow processing. All right, so now that we have everything set here, without even looking at how we can containerize this, we need to provide the connection string for our Azure storage. Now, there's 2 reasons for this. Is because our queue is there, our message queue is there, and the Azure function itself needs to store some information about its state. I have already a connection string that I prepared before for our storage. I'm going to paste this in. Now, save. If I go back to my environment here and just say func start, all what this is normal and typical way of running functions locally. This is I haven't brought anything new so far. Now we don't want to do this, do we? We want to run this in a container. This is where things become more interesting. So the team, through the core tools CLI, Azure Functions core tool CLI, provided ways for us to do this. So if we say function and init, this time we say, let me cheat. I love to cheat. This is the best way to learn. just put the commands out there and init and Docker only. Yeah. All what we want to do is to create a Docker file that is going to help us containerize, you get it, our function. So in our case, let me just clear. I'm going to say func initialize, but I just want the Docker file. Once we do this, you'll see that we have created another Docker file and a Docker ignore file. Let's examine the solution again and open the Docker file. This is where the interesting part is. This is where it becomes very interesting. The first thing you'll notice that the base image that we are building our Docker image on is the .NET Core SDK. Because we are building a .NET function, we need the SDK to build our function. The couple of steps afterwards are the steps that build the function, build the project, and publish it to the output folder. But then we have another image that is provided from Microsoft, which is called the Azure Functions /.NET version 3. This is not the .NET Core SDK. This is an image that has the runtime of the Azure function that is supposed to run .NET functions. So we are saying, okay, based on this image, provide these environments, and then copy the output of our build step here. Copy the output to the final image, and then the final image will have the runtime with our Azure functions baked on it. So if I go ahead and say Docker build this folder and provide a tag and call it my func image. Before we do this, let me make sure that I have my Minikube. See, I would have screwed everything if I didn't notice this. So I'm gonna start my Minikube cluster. Minikube is my preferred environment to run Kubernetes. Of course, this is not necessarily the best for everyone. There's the Docker for the Docker desktop application also has Kubernetes environment that you can use. It's just a matter of preferences and what you are used to and stuff like this. So once we have Minikube running, I also use the Minikube environment as my Docker daemon. So I construct the Docker CLI to use the Docker daemon in my cluster. I hope I'm not confusing anyone with this. There's going to be a lot of these small caveats here and there. So I hope you. Sorry again.
Is it possible to make the console a little bit bigger? The text on the console.
Yes. Look. All right. Fair enough. Let me see. I'm very novice at these things. All right. Preferences, I think, and then appearance, and then no. Closing window, selection preferences. Oh man, I think it's this one. Window, tabs, panes. There must be an easier way. Maybe there's a zoom, profile, view. Make text bigger. Yes, of course, it's Command and plus, of course. What I was thinking. Okay. Sorry for this.
Thank you.
I hope this is good for everyone. All right. We have our cluster running. Let's tell Docker that we want to use the Docker daemon in our Minikube as the Docker daemon. So we were saying Docker build this folder with a tag called my func image. Once we do that, because I've already had the layers before, it was very fast. So if I prompt us to see the images that we have, we are going to see that I have an image for us ready to be run. All right, so if I say docker run interactive my func image, we will be able to run this beautifully, but there's one caveat. You can see that here in our Docker file, we also, once we created the Docker file, we also created a Docker ignore file. This Docker ignore says, don't bake the local.settings.json with our environment because we don't want to put the connection strings and all the properties within the environment. We need to pass it as environments. So for that, we are going take these properties and put them as environment variables. Then copy the connection string. Oops, I do this all the time. Just bear with me. Copy the connection string, paste it, and another environment variable for the Azure function environment, which is going to be .NET. Now, if I run this, you can see that we have an Azure function that is listening to our queue running in my local environment. If I put this on the side and open Explorer, our queue Explorer, or storage Explorer, and navigate to our queue down under, you'll see that we have this queue. Let's add a message. Hello, Bill and Dan and all. Now, if everything is running smoothly, we'll see that this message will be picked up by our container and will process our message. In our, you can see that it's working beautifully. So by this, we can grab this Docker container image, put it on Docker Hub, and wreak havoc. Like, let anyone who wants to process messages in the way that we are running it, like, just put that Docker container, run it, and provide the right environment variables for yourself, and you're gonna have a running function, which is awesome. At least the way I see it. Cool. So now that we have Azure Functions running in a container, this means that we can probably put it in a cluster. So let's do this. This brings us to the next step. The next step is that we want to create manifest files like kubectl or Kubernetes manifest files that create a deployment in our cluster that has this container as a deployment. Also, the Azure Functions team beautifully created a way to create this for us. So we say function Kubernetes this time. Let's examine the subcommands that we have for Kubernetes. Function Kubernetes. I want the ones that are specific to Kubernetes, if you please. Yes, we have install. I'm going to come to install in a minute. And we have deploy. We provide some parameters for the deployment, and remove. I'm also going to come back to remove. So if I say function Kubernetes deploy, the name I'd like to use is my func deployment. And then the image name is the name that we just created. And because we are using an image inside our cluster, and we don't want to build an image locally and then publish it to Docker Hub, because Azure Functions CLI can do this. I'll show you in a minute. For now, we just want to use the image that we have built within the cluster. So we will say, actually, no Docker. But I'll not just run this. What I will do is I'm going to say, give me a dry run. Dry run means I don't want you to take this all through and run it. Just if you were supposed to run this command, what is the results that I can do? This will split a manifest file for us. So I'm going to write it to the deployment file. Beautiful. Let's open the solution again, and let's examine this deployment file. You can see that once we like the result of this function Kubernetes deploy, we have a manifest file that has the secret. it has the connection string to our storage. It also has a deployment that is using our func image, my func image. There's also another part that I'm going to comment. So at the moment, I will not ignore it. I'll come back to this later because we need it. But just to bear in mind that we have to do this. If I run this manifest file, we will have our Docker deployment, or we'll have our function image container running in the cluster. The last thing I'll just need to do, because this is running locally, we haven't pushed this image to Docker Hub, we need to tell Minikube or the cluster to not to try to pull this from Docker Hub if the image exists in the Docker daemon. So I'm going to say image policy is only pull if not present inside the cluster. I hope that these small little tips might be beneficial. I hope it's not overwhelming. Please let me know in the feedback towards the after the presentation, or maybe during, I don't know. All right, now I think we are ready to say kapply, or k is my alias for kubectl. Kapply the file deployment that we just created. Let me make sure that we have said, yes, we said it. So let me show, before do that, say git deployment. We don't have anything. Now kapply the file that we have created. Now we have created the secret, and we have created the deployment. So if I say git deploy again, git deploy, we can see that we already have a deployment of a single instance running. So if I go back again and throw another message, this is an old one, I'm going to refresh, there's nothing inside here, and say hello Kubernetes, and okay. Let's see git pods. Let's see what pods we have and get the logs of the pods that are running. And you can see that Azure function is running inside. I'm gonna say watch, oops, or follow. Means keep giving me the logs of this pod. And finally, it worked and it picked up the message. Beautiful. So now, if I stop this one, back to the presentation, we have a deployment within our cluster that is listening to our messages. Awesome so far. But what if I start receiving more messages? Since I have a single deployment with a single instance, I'll be overwhelmed. Of course, I can manually intervene and say, all right, you know what? I'm gonna spin more instances right now, or I can use metrics on the CPU and RAM, but this is gonna be reactive rather than proactive. So it's gonna be a problem. This is where KEDA comes in. KEDA is an open source project that is created by Microsoft in collaboration with Red Hat. KEDA is an operator that sits in your cluster, and by providing the right configurations, it can listen to the resources that you want to scale your deployments for. In our case, we have a queue, and it can go very large. KEDA will be listening to this queue and seeing and measuring the size regularly. Once it sees that there's a burst in the messages, it will create many instances for me. Once the messages or the amount of messages are smaller, KEDA will also realize that now we don't need to have so many workloads and instances of our Azure function in our cluster. Then I'm going to scale down. KEDA is really awesome because it's not just about Azure Functions. You can point it to any deployment in your Kubernetes, and it's going to do this for you. I created an extension for KEDA that if you send a chat kaboom, it will scale your cluster. So it was so much fun to do it. All right, now that we have our cluster, we can't scale right now without KEDA, right? So this is where the function Kubernetes install comes in. We said we're going to come back to this one. In our case, we don't have KEDA installed our cluster, so I'm going to say function install. I'm going to say only KEDA. Normally, you don't want to just say KEDA. There's a lot of things that it comes along more than KEDA. But because we are concentrating on the queue triggers for now, KEDA is going to handle this. But if you want HTTP triggers, you don't want to say KEDA only. You want to just install because of the other components. I don't want to complicate things more. So function install KEDA. We will see that what happened. There's something wrong. Func Kubernetes install only KEDA. All right, now it's working. Now it has installed KEDA in my cluster. So if I say git deploy, you'll see that we also have another deployment that's called KEDA. This is where we come back to our last piece of the puzzle, which is the scaled object. This is what we commented at the moment. The scaled object is a resource that is only specific for KEDA. So this is a configuration that you put in your cluster. You say KEDA will pick that up and say, all right, you want to scale the deployment, my function deployment, based on a trigger of type Azure queue. And the name of the queue is my queue items. Awesome, I'll do that for you. So we have to apply again. Apply the file again. You'll see that because we haven't changed anything in the deployment, my function deployment, nor in the not in the secret, nor in the deployment, nothing has changed. But we have the scaled object created for us. To test this, let's first of all get our deployment, and let's watch it. Watch it means like keep it running, and let's see the numbers. You can see that we have zeros of zeros. We don't have any instances at the moment. I will create a new terminal on the side, and I will also cheat from my cheat sheet. I have a very nice command that uses Hey. It's a CLI. It just creates a lot of HTTP messages for you. We are writing 200 messages by one go to our queue. So once we hit this, you can see that we have 200 responses of 201, like means created. And if we check the messages, it's created. Now let's keep an eye on the left side here and see how if we do things the right way, like, because these demos, they can easily screw up. If we did everything correctly, we will start seeing that the instances are being increased because we have sent a lot of messages. It's coming. KEDA, every 30 seconds, looks at the queue, says, all right, we have a lot of messages right now, and based on the default configuration, we are going to deal, I think it's 5 messages per Azure Function instance. We have 200, then divide by these two, you'll get, I think, 32 or 40 instances running for this. So you can see that it's increasing the instances as we are going, and if we check the Explorer here, you can see that we are the messages are being consumed and they are done. The thing is that once it finishes, it does not finish instantly. Like, it's not going to scale down on the spot. It's going to have 5 minutes cooling period until it makes sure that everything is fine, and then it's going to start taking down these instances. Of course, this is like there's a lot of details in this. Like, I'm sorry, we are in the Kubernetes world. There's a lot of complexities. There is a horizontal pod autoscaler that is built in Kubernetes that has this cool down period. So you have to configure it in your cluster, not through KEDA. All right, this is awesome. Now we have, what do we have? We have our KEDA is running fine. We just demoed KEDA. But then there's another problem. What if there's more load? Now, in the Kubernetes world, even in the managed Kubernetes world with AKS and the like, you will probably have a node pool with a couple of nodes that are running to which you schedule your workload and the pods. In our case, it's our Azure function. But you are limited with these nodes that are sitting in your cluster. Once you want to you have an overload and you want to create a new node, creating a new node is not as fast as you'd like, because you're going to spin a new virtual machine. It's going to become ready to be joined to the cluster, and then configured to join the cluster. But it's going to take some time, and sometimes you are in so much pressure that you cannot just take that. This is where Virtual Kubelet comes. Virtual Kubelet is also an open source project that is, I think it's started by Microsoft and given to the community, where it sits in your cluster, and you can configure it to connect to whatever cloud provider you like, and it's going to say, it's going to act as a virtual node. So it's say, if you have more loads, I can take them, and I'll spin instances outside of the cluster, but as far as you are concerned as a cluster, they are within the cluster, but they are not in reality. In Azure AKS, the virtual kubelet is an option. You can just tick it on, and behind the scenes, it will use Azure Container Instances, which is the service that Azure provides to spin a container on the spot from an image, and you have something that is running. All right, so this is the virtual kubelet. Let's have a quick look on if we can have time to see if we can demo this without disasters. Let's demo kubelet. All right, going back to this. Before continuing, I will destroy our cluster here, because we are going to create more messages just like before. But we want to utilize the virtual kubelet. We don't want this cluster to steal our messages from us, because we are going to use the same storage. So I'm gonna say delete. Okay, delete all the resources that is created by the file deployment YAML, and now we don't have anything. I'll switch to my context to an Azure AKS cluster that I created before, and I configured the virtual kubelet as like I said before. It's just a ticker box. The only thing that you have to be careful with is that you have to create your cluster in a region that supports virtual nodes. Otherwise, you'll not be able to. This option is going to be grayed out. So I'm going to git the config and see what context I have. It's the my virtual, yes. So config use context the my virtual cluster. Awesome. Now that we have pointed our kubectl to that cluster, we have a small problem. Now that we are not running it from within our local environment, now we are talking about the cluster in the cloud. And if you are going to deploy your Azure function to the cluster, to the cloud, it has to pull the image from somewhere, and it can pull it from your local machine. So the good thing is Azure Functions as well in the CLI has the built-in functionality to build your image, push it to the Docker Hub, create the deployment files or the deployment manifests, run it on your existing cluster. All this is for you, and then pull the images from Docker Hub. For that, let me open a new browser. Let me bring it forward to this screen. I'm gonna dock it to the right side, and I'm going to go to Docker Hub to show you that I've done this before. This is not my first trial, so I'm cheating. This is not my function one. It's probably more than one. So, but I only have these two images now. What I will do is I'm going to say function. What I'm going to do? Function Kubernetes. Function Kubernetes deploy. Correct? Deploy. The name I'm going to provide is going to be my function. This is going to be the name of the image. The registry I'm going to use is Alashi. I already have used Docker CLI before in my CLI in my terminal, and I already logged in. So it has this session ready. So if I say function Kubernetes deploy, the name of the function and the registry, I hope I didn't screw anything else. If I run this, you can see that it's trying to build. It's already built because we have the layers already there. And now it's pushing to my Docker Hub. I'm not sure how long this will take. And then once it pushes my image to Docker Hub, it will, the manifest files that it generates, it will run them instantly because we didn't have the dry run. It will run them instantly on the cluster, and we will have our Azure function there. What else should I say until this finishes? Yeah, there's one step also we need to change afterwards, which is once you create, like in the virtual kubelet, the way that you can configure your deployments, you can be selective on which nodes you want to run your workloads. And my understanding is that virtual kubelets will avoid to run the things that are normally run on the main nodes. So we need to, for our demo purposefully, we need to change the configurations of our manifest to say, you know what, for this deployment specifically, just run them on the virtual nodes. And hopefully this will guide the scheduler to say, grab the deployment, all right, you want this on virtual nodes. It will talk to the virtual kubelet within the cluster, which is already configured to connect to the Azure container instances. And then we'll create the pods in the Azure container instances and make them as if they are within our cluster. I don't have more words to fill this to fill this gap, so I'm hoping that at some point.
Is there anybody have questions? If you do
Yes,
have questions, go ahead and through the question and answer. There should be at the bottom of your Zoom screen. Just put them in that question and answer. There's nothing at the moment, but
thank you, Bill, for saving me.
Yep.
All right, so we have a small problem. Can you guess? It's complaining about scaled object, of course, because it does not understand the scaled object that we have created in the manifest file, because we didn't install KEDA. It's a very clean cluster. Okay, let's do this again. The deployment is there, but the scaled object is not there. So what I will do is just, I'm gonna do a dry run of what we have just did before. But then just steal and just steal the scaled object instance. Function Kubernetes deploy my name and registry dry run, and then write it to deployment virtual.yaml. All right, so let's see if this happened successfully. Deployment virtual YAML. It's error, passing registry. When set Docker build is run and the image is pushed. Okay, so it's complaining about my, okay. I think it's Alashi. We deleted this by mistake. Let's try this again. And awesome, it worked. Okay, let's take this, all of this, delete, and we have just the scaled object. Before we create the scaled object, I want to create KEDA in the cluster. So no, not K, function Kubernetes install KEDA. Also, I forgot another thing. We want also to do what? We want also to change the deployment so that it selects the virtual kubelet. Let's open my cheat sheet. I have this bit that says, please run specifically on the kubelet. And I think it sits here because YAML is very awesome. So we're going to put our toleration here, and hopefully we haven't screwed anything. So I'm going to apply file that we have created, the virtual one, and see if everything goes fine. All right, the my function hasn't changed, the secret hasn't changed, the deployment has changed because we put that selection on the selector, and then we also created the scaled object. Now, go back to our Explorer, there's nothing here. Go back to our terminal, the second terminal. We want to run this again, but then let me, before I run that, be prepared. So I'm going to say git deploy and watch it again. So we are going to run this. So we have created our 200 messages, and then we will wait for the seconds until KEDA discovers the 200 messages and scale our cluster. You can see it is scaling. Awesome. In the other hand, if we say, you know what, the window is going to be very small. Let me exit this one. I'll stop this because I know it's scaling. I would say git pods, but I want the output to be wide, and I want to watch it. And this is where we are. I'm showing that in the node that is being selected is not the agent pool, not the normal pool that is being created with your cluster. It's actually the virtual node ACI Linux, which is the Azure Container Instances. Now, if I'm fast enough, let me try to put the portal. I should have put this before. It's the wrong tenancy. Let me change it. Switch to this account. Just give me 1 second. And then container instances. You'll see that we have a bunch of container instances that are created for us. And you can see that my money is going down because it's Kubernetes. So you can see that it's creating Azure container instances for us. The good thing is that once it finishes, you'll see these container instances going down again. You'll not do anything. You'll just pay for them while they are being used, and then you stop paying for them once you stop using them. All right. This is awesome. I think we finished all the demos successfully. We come back to the presentation. You have seen that with Azure Functions, you can deploy it on Kubernetes. You can scale your Azure Functions using KEDA. And you can expand your pods out of your cluster using virtual kubelet. All of this you can do with, you don't have to go through all of what we have done today. You can just go through the last couple of commands that we did, and the Azure Functions core tool CLI will do this for you. Of course, there's going to be a but. Yeah, you don't get this for nothing. There's two things I didn't really enjoy. The fact like it needs to be better. The first one is that there is a hard dependency on Azure storage. The Azure Functions, if I bring this here, the Azure Functions use blob storage to keep their state. And up to the moment, and up to my understanding, that this is needed regardless where you run your Azure Functions. You run it locally, you run it unless you use an emulator and use development environment tag. If you want to really use the real thing, you have to have an Azure blob storage somewhere. I wish that at some point this becomes like a provider, some sort of a provider, and you provide the implementation yourself as a configuration to use something other than Azure blob storage. The other limitation is limitlessness. With Azure Container Instances, like any other cloud provider, that there are some constraints on what resources you can use, and I think you can only create 100 instances per subscription. But the instance is a container group. The container group can contain up to 60, I think, 60 containers within the group. But then 60 plus 100 times 100, you get probably 600. But there's limitations. Yeah, the idea is that there are limitations, and it's per region. And also there are some limitations on how you can use the virtual kubelet and some other limitations in that space. I put these limitations and links and everything that you like every resource I came across to do this presentation, I put them under this link. You can QR code it. You can capture the link from Bitly. If you it's just a bunch of links in my GitHub, or just I don't know how you pronounce it. And then if you have any feedback or any questions, I'll be very happy to take them. Thank you so much.
So far, there's no questions. Does there anybody have a question? So thank you very much, Emad. That was really good. It gave me a lot of things. I'm working on some training material for a client at the moment, and there's a lot of those topics that are going to be on the training. So it was a really timely thing for me, and I enjoyed that. And I think that we're seeing it as a consulting firm in 6pivot. We're seeing a lot of people talking about containers. We've also seen a lot of things with the tenders and stuff that we've seen recently around even integration architecture. There's a lot of container items showing up in there and things like that around people wanting to put stuff in VNets, and it's a cheaper way to do that at the moment. So I don't see any questions. I would like to thank you again and thank everyone for attending tonight. And for those people that have other people that are interested in this talk, it should be up on our Integration Down Under website, which is integrationdownunder.com. And it should be up there tomorrow afternoon so that you'll be able to point people to that if they want to listen to this talk again. Thank you very much. And I think that's going to be it for our session tonight. And again, thank you, Emad. And
thank you. Thank you.
Yeah, thanks
everyone for attending.
Awesome.
Thank you, everyone. Cheers. Thank you.